this can be simplified as 4 to the power of y multiplied by 4 to the power of negative 2 equals to 40. This is the rule of indices. Now, here we have 4 to the power of y. This is the same thing as saying 4 squared. Okay, the negative can be converted to division. Why? Because if you have y to the power of negative a, it is the same thing as 1 over y to the power of a. And this is equals to 40. So here, I'm going to have my 4 to the power of y. 4 squared here is 16, which is equals to 40. Now, we can write this as saying 4 to the power of y equals to 40 multiplied by 16. Now, from this, we can apply the rule of log reading. Now, this is going to be the log 4 to the power of y equals to the log of 40 multiplied by 16. So, from here, we have, if you look at this carefully, if you have log a to the power of b, this can be written as b log a. So I'm going to use the same approach to solve this, and here I'm going to have y log 4 equals to log 40 multiplied by 16. And now I have my y log 4 equals to log 40 multiplied by 16 can be written as 4 times 10 times 16 is the same thing as 4 squared. So from here, we can have have y dividing both sides by log 4. So here on this left hand side, log 4 is going to cancel out log 4. So here is going to be y, which is equals to log, this is 4 squared because we have 16 initially, and 4 squared multiplied by 4 is going to be 4 to the power of 3 times 10 divided by log 4. Now, here we're going to have y equals to log 4 to the power of 3 plus log 10. This divided by log 4. And from here, both of them can share the same common denominator, because there's something about fraction. If you have a plus b over c, this can be written as a over c plus b over c. So this is the rule I'm going to use here. So here I have my y to be equals to log 4 to the power of 3 divided by log 4 plus log 10 divided by log 4. So this is the rule I'm going to be using. And from here, you can easily have y to be equals to, also here, if you have log a to the power of b, so this is the same thing as saying b log a, just move this behind. So I'm going to be using the same law here. So this is going to be 3 log 4 divided by log 4. plus log 10 divided by log 4. Now, from this also, we can cancel out log 4, log 4. Why? Because they are the same. And from there, we're going to have y to be equals to 3 plus log 10 divided by log 4. Now, another interesting fact is this. If you have log A over log B, and they have the same common denominator, the same common base, this can be written as log A base B. Okay, provided they have the same base initially. So I'm going to use the same law here. So here, my y is going to be 3 plus log 10 base 4. Now, this is what we've gotten. But how can we be sure if this is accurate? Now, recall from the problem we have initially that our question is 4 to the power of y minus 2 equals to 40. Now, I want to verify if this is actually true. So now I'm going to plug in the value of my y here. What we have here is going to be plugged in here. Now here I'm going to have 4. My y is 3 plus log 10 base 4 minus 2. So we want to confirm if this is going to be equals to 40. So from here, I'm going to have 4. Here we have 3 minus 2. Okay, if we remove the parentheses, log 10 base 4. So we want to see if this is actually equals to 40. Now, from here, we're going to have 3 minus 2 is 1. So we have 4 to the power of 1 plus log 10 base 4. So we want to see if this is equals to 40. So by using the law of indices here, we're going to have 4 multiplied by 4 to the power of log 10 base 4. So here we have, there's another rule I'm going to teach you right now that says that if you have a to the power of log b base a, if the base of the logarithm and this value here is the same,